Let's take a look at the sum from 2 to infinity of 1 over n log n. The first thing we can quickly do is check the divergence test. Now, recall that if the limit of the terms to infinity is not 0, then the sum will diverge. N log n goes to infinity as n goes to infinity. So, the limit of the terms will be 0. Therefore, the divergence test doesn't tell us anything. But even though it doesn't tell us anything, it gives us intuition about the function 1 over x log x. Notice that f of x is decreasing for x bigger than or equal to 2. That's because x log x increases as x increases. Or alternatively, you can verify that the derivative is negative for x bigger than or equal to 2. Next, f of x is non-negative for x bigger than or equal to 2. That's because x log x is positive for x bigger than or equal to 2. Also, f of n matches the terms of the series for all integers n bigger than or equal to 2. Finally, f of x is defined and continuous for x bigger than or equal to 2. Now, with these 4 things, we actually satisfy all the conditions we need for the integral test. Recall that we need f to be defined and continuous, to be decreasing, non-negative, and to match the terms of the series. If all of these are satisfied, then the sum will converge if and only if the integral converges as well. This if and only if means that if the integral diverges, then the sum will diverge as well. In our example, big N is equal to 2. So with all this in mind, let's take the integral of f of x from 2 to infinity. We'll apply a u substitution with u is equal to log x. Du will be dx over x. Substituting, we'll find now we need to evaluate our answer at the limits. And we'll see that this tends to positive infinity. Hence, the integral diverges, which means, by the integral test, that the original series diverges as well.